Given the equation y equals 18 times cosecant of the quantity 15x minus 30 plus 5, determine the period, amplitude, horizontal or phase shift, vertical shift, and range. Let's first factor 15x minus 30 so it fits the form of the cosecant function shown here on the right. This gives us y equals 18 times cosecant of the product of 15 and the quantity x minus 2 plus 5. Now let's determine the values of a, b, c, and d. Notice a equals 18, b equals 15, c equals 2, and d equals 5. The period is equal to 2 pi divided by the absolute value of b. b equals 15, the absolute value of 15 is 15, and therefore the period is equal to 2 pi divided by 15, which does not simplify. Next, we're asked to determine the amplitude. Looking at the graph of the basic cosecant function, notice there is no minimum or maximum, which indicates there is no amplitude, and we enter none. The horizontal shift or phase shift is determined by c, because c is positive 2. The function is translated right 2 units. The vertical shift is determined by d, because d is positive 5. The function is translated up 5 units. And now to determine the range, which is a little bit more involved. Let's first determine the range of the basic cosecant function shown here on the right. Focusing on this piece of the graph, for the range we'd have the interval from negative infinity to negative 1, including negative 1. Union, analyzing this piece of the graph, the range also includes the interval from 1 to infinity, including 1. And now let's consider the range of y equals 18 cosecant x. Wherever the cosecant function value is negative 1, for this function the value would be negative 18, and whenever the cosecant function value is positive 1, the y value for y equals 18 times cosecant x would be 18, which means the range for y equals 18 times cosecant x would be the interval from negative infinity to negative 18, including negative 18, union the interval from 18 to infinity, including 18. And now let's consider the range for our function. The only other value that will affect the range is d, the vertical shift of up 5 units. Having a different period or a horizontal shift is not going to change the range. So now let's consider our function. Shifting the graph up 5 units is going to increase the negative 18 by 5 and increase the positive 18 by 5. The range is going to be the interval from negative infinity to negative 18 plus 5, because the graph is shifted up 5 units, union the interval from 18 plus 5 to positive infinity. This would be the range for the given function. Let's go ahead and list it above. We have the interval from negative infinity to negative 18 plus 5, which is negative 13, including negative 13, union the interval from 23 to infinity, including 23. And now see if we can verify these results graphically. It's going to be hard to verify the horizontal or phase shift of right 2 units because the period is so small. Here's a graph of the given cosecant function, as well as a related sine function. If we graph y equals 5, this does verify the vertical shift up 5 units. We can also verify the period is 2 pi divided by 15. Again, it's hard to verify the horizontal shift of right 2 units, but let's verify the range. Focusing first on this piece of the graph, we'd have the interval from negative infinity to negative 13, including negative 13, and then focusing on this piece of the graph, we would also include the interval from 23 to infinity, including 23, as part of the range. So the graph does verify our results are correct. I hope you found this helpful.